What's going on, everybody, and welcome to the tutorial video for March 2018. I hope you're all doing very well. In today's video, we're going to be doing a little bit of math and a little bit of computer programming. But wait, before you click off this video, don't worry, it's not that difficult. The nice thing about doing math and computer programming is that the computer does a whole lot of the difficult math for us, so we don't have to worry about that at all. Anyways, in today's video, I'm going to be showing you how I have my players. As I've mentioned, the players in my game are 2D objects that are in a 3D space. And basically, I want my 2D players to always face the camera no matter where they are on the map. And so with this, we don't need to worry about the height of the camera. So if the camera is way up here, it's still going to be facing forward. It doesn't need to tilt upwards or anything like that, because I still want these to feel like kind of like they're cutouts placed in a 3D world. So the main effect is basically that no matter where my camera is, the player is going to face the camera at all times. Again, if I go downwards, it's not going to tilt downwards. It's just going to stay flat like that. But as an added bonus, at the end of this video, I am going to show you how you can do it, where if you tilt the camera down, it's always going to face the camera no matter which way you're pointing. This is an effect known as billboarding in the computer graphics world. Now before we jump right into the code, I'm going to show you how this works on the whiteboard, because it is only like 3 lines of code. So I'd just really like to explain to you guys what's going on, give you a visual representation, so you don't get lost in like the 3 lines of code that we have to write. So basically you'll see here we have our coordinate system. This is kind of a top-down view. So we have the x-axis going this way and the z-axis going this way. And then somewhere in our scene we'll have our player, and then so this is the vector that represents the position of the player. And then somewhere else we'll have our camera, and this is the vector that represents the position of our camera. Now basically all we want to do is rotate our player a certain amount of degrees to face this camera. So if you can think of this as facing forwards and then this is facing the camera, basically we just need to find this angle right here. Now how we do that, first we need to figure out what this vector is. And that's just simple vector subtraction. You're going to take the position of the camera and then subtract the position of the player, and the resulting vector is this right here. Now we're just going to use a little bit of trigonometry. We're going to use something called the arctangent, specifically the tan2 function. And what that does is it gives us this angle right here between the positive x-axis and whichever vector is our target vector. The nice thing about the tan2 function is that it accounts for whatever quadrant it's in. It's going to give you the correct angle, so you don't need to like flip the angle as negative if the camera was over here or something like that. That's all taken care of for us. And then one last thing we need to keep in mind is that the positive y rotation is actually going this way. So once we find this angle, we just need to multiply it by -1 when we're setting our rotation, so we rotate this way towards the camera instead of away from the camera. Okay, so here we are in our script. This is the unit controller script. So this is the script that's attached to every athlete in my game. And so basically I have this function called the rotate unit sprite, and like I said, it literally only has 3 lines of code. So the first thing is we're going to get our target vector. And again, that's just the camera's transform position minus our transform position. Now in this line, we're going to declare a new float variable called new y angle. And this is where the arctangent function comes into play. So all you do is mathf.atan2. And the way you pass in the variables is you want to actually do the y variable first. Which in this case is our target vector.z. I hope that's not too confusing. And then the x variable. So it's just target vector.x. And then the result of that is actually in radians. So we'll need to multiply this by mathf.rad2degree. So basically all that does is just converts it from radians to degrees. Very simple. And then the last step would be to set the player's transform.rotation using the quaternion.Euler function, which basically lets you pass in x, y, z rotation values to get a quaternion which is what Unity uses to keep track of rotations. And again, we just need to multiply that new Y angle by -1 so we rotate in the correct direction towards the camera, not away from the camera. So without further ado, let's see it in action in my game. Okay, so here we are actually in the game, and you'll see that as I rotate the camera, the players rotate and they're always facing towards the camera. Now this effect may be a little bit easier to see up in the editor view, so I'll show you it again. You can see as I rotate the camera, the players always rotate only on the Y rotational axis. Again, they're not facing directly at the camera, their just Y rotation is oriented towards the camera. And as promised, here's a little bonus section for you. Again, this is how we get something to billboard so it always faces the camera in all directions, side to side and up and down. So basically, in the awake function, I just have this variable called mCamera, and we just set that to the camera.main. That just makes things a little more clean in this case. And in my case, I'm actually doing this just directly in the update function because I want it to happen every single frame. And so what we do is, again, we have a target vector. However, this time we're going to do the transform.position of the current object, and then we're going to subtract the main camera's transform.position. And then all we do is set our transform.rotation using the quaternion.look rotation, and we'll pass in the target vector, which we just found up here. And then for the second variable that we plug into the look rotation function, we just want to know what the relative up axis is. And in this case, we want it to match the camera's transform.rotation.y, and so basically we can just do m.camera.transform.rotation, multiply it by vector3.up, so it just zeroes out the x and z values. Alright, so here we are back in my game, and you'll see that if we move one of the players close enough to one of the enemies so we can attack them, and we do attack them, we get this little damage icon that hovers above the enemies here. And you see that this always faces the camera, and I want it to be like that so we always have the best view on this little UI element here. Again, let me move one of these guys a little closer and make the attack, and I'll show you this up in the editor mode. You can see that it rotates and it even tilts up and down as my camera moves up and down in the y-axis. And then one last time, I'll show it off here. So anyways, that's just about going to do it for this tutorial video. Again, those are two different ways that we can make 2D objects face our camera. Again, one way only does side to side, where when the camera's up here, it's still going to face directly forward. And the other way is billboarding, so it follows the camera side to side and up and down. So I hope you found this video useful. If you did, please give it a like. If you have any questions for me, feel free to drop them down in the comments section below. Make sure you subscribe to the channel for some awesome content if you haven't done so already, and I will see you in the next video.